Our Sun gives a steady stream of warmth and light, bathing Earth and the rest of our solar system in energy. But be warned, it has a temper too. The Sun is a boiling, seething, angry star, and solar flares, eruptions and other sunstorms can have serious effects on satellites and other systems around or on Earth. Some of space weather can be visually stunning, such as the northern lights, but geomagnetic storms and coronal mass ejections can be a danger to spacecraft, astronauts, and life here on Earth. The study of these phenomena has spawned a whole new branch of science, known as heliophysics, so explore this room, to discover the true power and might of our closest star. Astronauts on the International Space Station used a digital camera to capture several hundred photographs of the aurora australis, or southern lights, while passing over the Indian Ocean on the 17th of September 2011. Have you ever seen a plasma lamp? Or maybe neon signs? What about a plasma TV screen? These all contain the fourth state of matter, known as plasma. But just what is plasma? A plasma is a gas that is so hot that some or all of its atoms have split up into electrons and ions, which can move independently of each other. Because the particles in a plasma have an electrical charge, they are affected by electrical and magnetic fields. Plasma can be found throughout the solar system and beyond. For example, in the solar corona and solar wind, in the magnetospheres of the planets, in tails of comets, in intergalactic space, and in the disks around black holes. Earth has a magnetic field that runs from south to north. This creates the magnetosphere, which protects us from most particles from the Sun. When a coronal mass ejection arrives at Earth, it befriends the magnetosphere. If the arriving solar magnetic field is traveling in the opposite direction to the Earth's magnetic field, the two collide and interact. The Earth's magnetic field is then peeled open like an onion, allowing energetic solar wind particles to stream down and hit the atmosphere over the poles. This causes a magnetic storm, which involves a rapid drop in the Earth's magnetic field strength. This decrease lasts about 6 to 12 hours, after which the magnetic field gradually recovers over a period of several days. Each white dot in this image represents an object in orbit around the Earth. One serious problem that can occur during a geomagnetic storm is damage to Earth-orbiting satellites. The ring represents objects in geostationary orbit such as many communications satellites. Due to their large distance from Earth, they are much more susceptible to damage from solar particles. The swarm of objects closer to Earth includes objects such as the International Space Station and the Hubble Space Telescope. They are much better protected due to their proximity to the Earth's magnetic field. Flares are our solar system's largest explosive events. They are seen as bright areas on the Sun, and they can last from minutes to hours. This speeded-up video shows two Class 10 flares that happened an hour apart, in the morning of the 10th of June 2014. X-class denotes the most intense flares. Auroras happen on other planets too, especially Jupiter, creating a spectacular glowing ring around the poles. Not only are the Jovian auroras huge, they also contain hundreds of times more energy than auroras on Earth. And, unlike our own northern and southern lights, Jupiter's light display is never-ending. There are four fundamental states of matter, namely solid, liquid, gas, and plasma. The particles in a solid are closely packed together, and cannot move freely. As a result, a solid has a fixed shape and a fixed volume. If a solid is heated above its melting point, it becomes liquid. A liquid takes on the same shape as its container, but its volume doesn't change. When hot enough, liquids vaporize into gases. A gas has no definite shape or volume. Instead, it spreads out to fill its entire container. Finally, gases can be turned into plasma by extremely high voltage or temperatures. Plasmas are electrically conductive, produce magnetic fields and electric currents, and respond strongly to electromagnetic forces.
Oh, you saw me fall? No, I saw you teleport back up. Oh. Oh, is that you over there? Hang on. I'm here.